I would now like to introduce our second keynote speaker, Dr. Raquel Urtasun. Raquel is founder and CEO of Waabi, an AI company building the next generation of self-driving technology. Waabi is the culmination of Dr. Urtasun's 20-year career in AI and 10 years of experience in building self-driving solutions. In addition to heading up Waabi, Raquel is also full professor in the Department of Computer Science at the University of Toronto. She's a co-founder of the Vector Institute and the recipient of several high-profile awards, including the Longwit-Higgins Prize, the Everingham Prize, the NSERC EWR Stacey Award, 2 NVIDIA Pioneers of AI Awards, 3 Google Faculty Research Awards, an Amazon Faculty Research Award, and 2 Best Paper Run-Ups at CVPR in 2013 and 2017, and I could go on. In 2021, Raquel was named as one of the top 100 women of impact by Entrepreneur Magazine, one of the top 100 people transforming business by Business Insider, and one of Toronto's most influential Torontonians by Toronto Life Magazine. She was also named Chatelaine 2018 Woman of the Year and 2018 Toronto's Top Influencers by Adweek Magazine. Please join me in welcoming Dr. Raquel Urtasun.
Well, thank you. It's really a pleasure to be here, and there is nothing as exciting as really to be in a room full of the next generation of AI technologies. So I can't wait to, to see what you guys are going to achieve. So very, very exciting. And it's always an honor to go, after Jeff, which is, the godfather of AI, an incredible figure for all of us. Cool. So today I'm going to be talking about, a lot of the exciting things that we are doing at Waabi, and I hope that by the end of the talk, a lot of you are excited about building your own company and really bringing, this next generation technology to Ontario, as we hear from Minister Fideli. So at Waabi, we are building an AI-first approach to really bring self-driving trucks to the market once and for all. Hopefully this works. Cool. All right, so I think we will all agree that self-driving is one of the most exciting technologies of our generation. And once it's built and deployed at the scale, it's going to really transform the world as we know it today. Our cities are going to be greener. We're going to provide transportation for people that today don't have the means to go from point A to point B. We're going to save so many lives. At the same time, we're also going to solve the logistic crisis that we are all suffering today. How many of you are trying or waiting for, something that you ordered many months ago to actually be delivered to your house? At Waabi, we are very, very committed to bring this technology to logistics. And I founded the company a year and a half ago. And we are headquartered, very, very proud Canadian company, so headquartered in Toronto, as well as since day one, we actually have offices in the Bay Area, in San Francisco. Now, in order to build this technology, we fundraise, and I did it on the first day of the company. And this was, for those of you that want to be entrepreneurs, happy to share my experience. First day, I have a deck and an amazing team. And I went up, in front of all the investors, please give me $100 million. Right, sounds like an easy thing to do. It took me only 2 months to actually raise this money, which is super, super fast, right? And it was one of the largest, if not the largest, fundraise Series A in Canadian history. So there was a lot of excitement about what Waabi represents for the self-driving industry, and I'm going to tell you a lot about technology in the next couple of slides. What is important also is not necessarily just about, are you fundraising a lot of money? Is who are your investors that are actually going to be with you for the long-run journey? And in particular for Waabi, I wanted to have investors that were, super, the best in class in terms of deep technology, because we are, they needed to understand, our value proposition. What is this, next generation of AI systems going to do for us? So that's why I choose Khosla Ventures as the lead for our fundraise. It was also important to have logistics, so Uber as well as ABC. And lastly is, I'm not Canadian yet, but I'm very, very proud Canadian, I guess, or semi-Canadian. So it was important for me to have, investors that were also Canadian. For example, Omers, BDC, or Radical Ventures. Okay, so we are building something, we are not building demos, we are building a real commercial product from day one and a full stack solution. All right, so why trucking? Oftentimes people ask me, why not robotaxis? And former to forming Waabi, I was the chief scientist at Uber self-driving program, where I have I work with both self-driving trucks and self-driving cars. And for me, it's very, very clear that where this technology is going to deploy first is really in trucking. And there's two reasons for this. The first reason is about the business side. This is a $1 trillion market. How many markets do you know that are still out there that are $1 trillion, right? There is not that many. So that's pretty exciting, right? And I guess your investors excited. At the same time, there is an understanding in the industry, in the logistics and transportation industry, that because of the chronic shortage of drivers that is getting worse and worse every year, there is no other solution but automation. So everybody's preparing for the day that indeed self-driving is out there. So that's a great spot to be in. And at the same time, from the technology perspective, driving in our cities is much more difficult than driving in highways. And for trucking, typically, most of the driving that you need to do is on highways. Okay? It's still a really, really hard problem to solve. No solution exists yet. Okay? But if you compare of downtown Toronto, right, a highway, you can see that it's easier. All right, so where are we today? Since the DARPA challenge that was 2 decades ago, there has been meaningful progress. But when you look at commercial deployment, it's nowhere to be seen, right? There is nothing out there. When you go out, you don't see self-driving cars, self-driving trucks anywhere, right? And you probably are wondering, why is this the case? There has been so many billions of investment, right, and so many great minds, trying to solve this. Well, the problem lies in terms of the technology that has been employed to try to solve this problem. Okay, let's get a little bit deeper into what's wrong with this technology. So if you look at most of the competitors out there, what they are going for is a very robotic-centric approach, an approach that is very hand-engineered, where basically you have this very complex problem to solve, right? You have some observations from your sensors, and then you need to come up with the right solution for the maneuver that the vehicle has to do. And so you decompose this problem into a lot of tiny little problems that you give a very large team to solve. And then you hope that by this bottom-up approach, you will be able to somehow come up with the optimal solution or a solution that is great, right? It's extremely, extremely hard to do this. It's like building a puzzle by cutting independently pieces and hope that they will piece together right, in the right way. The other reason why this technology is not great is that the role of AI is actually really small. Some of these components utilizes AI, but it's very few of them. And the final decision process looks very much like an expert system. Rule-based, something that is not going to really solve the complexity of all the scenarios and things that might arise when you drive in the real world. Okay, so this is not great. And there is another thing that is even worse, which is that this technology, the way that they actually do the testing is by driving millions of miles in the real world in order to understand what is the next thing that you need to solve. What is my next problem to solve, right? That's extremely capital expensive, and it's really, really not the safest solution, okay? So we need a better way. Let's see what we can do. So let's bring an AI-first approach to try to solve self-driving. All right, so we just heard from Jeff Hinton today that using a black box approach is never going to give you interpretability, and we absolutely agree on this one. Okay, so when you think of an AI-first approach, the first thing that everybody thinks is like, oh, let's just use the neural net that hopefully will actually do this task well. Right? So the problem with this is that, yeah, it lacks interpretability. This is a safety-critical system, so validation verification is a must. A regulator is going to have a hard time letting you drive on the real world if you cannot validate and verify your system properly. Okay, so that's something that is very important. Furthermore, on top of this, it's really hard to make progress because there is very little notion about what these architectures are doing. And on top of this, you need so many examples in order to learn for these systems to actually drive well on the road. right? So think about the system has to handle accidents or near like accident safety critical cases. You're not going to go and collect data of accidents, crash your system, on purpose so that you can learn to do that better, right? This is definitely not something that you can do. So we need a different solution. All right, so what are we doing at Waabi is trying to bring the characteristics, the best characteristics of these two approaches without inherently their disadvantages. So what does that mean? Is that we're going to build a modular, interpretable approach, but it's still going to have the possibility or the ability to learn end to end. So we have the automation, right, of being able to train the entire system at once, right, so that enables us to develop much faster than any of our competitors. But at the same time, we have modularity, we have interpretability, so that we can validate and verify the system. And Jeff alluded to this before, is that you need one more thing that is also like super key on for really solving self-driving, which is you need to be able to really control the world and generate all this large number of examples in a way that is reactive and immersive. And that's our next generation simulator, which is our second differentiator. Not only our brain of the self-driving vehicle is different, but also we have next generation simulation that really enable us to test at the scale and train the system at the scale. Okay? So this results in a much more scalable and affordable solution. All right? And why is simulation important? Right, because, and you probably are thinking, but all these companies are talking about simulation. Raquel, what are you talking about? What's your simulation, why aren't they doing the same thing as you are doing? So what happens is that simulation systems in the industry are very, very primitive. So yes, everybody uses simulation, but it's just a tool and a set of tools that gives you just a little bit of signal. So you still need to drive millions of miles in order to understand how your system performs. Okay, so at Waabi, we are inverting this pyramid of how much real-world data you need to collect versus simulation, right, by building this next generation simulator, okay, which we call Waabi World. So let's look at it, and now I'm going to just show you a whole bunch of videos, okay, so it's going to be more entertaining. Let's look at why is the simulator so special. All right, so hopefully this plays properly. So our simulator, first of all, you need to create a simulator that is super high fidelity. A simulator that works in real time so that you can really do this at scale in the cloud. A simulator that is reactive, meaning that your actions are going to have an impact in what the simulator is doing, and what you see in the simulator, you are actually going to react to it so that it really tests the same as if you were driving in the real world. Okay? So there is a few core components that you need to create this next generation simulation. First, you need to be able to create the virtual worlds in a way that really captures the diversity and complexity of the real world. Okay? The way that we do this is by digitally cloning the environment, the world, using our AI algorithms. This means that every time that we drive a vehicle on the world, we can directly import automatically everything that we see as part of the simulator. Every single street, every single pedestrian, every single vehicle that you observe is directly part of the simulator. This scales super, super well, and is very realistic. Then we need to be able to simulate the sensors, right? Because in order to test the entire system, you need to be able to simulate what will be the same input that it will be in the real world, right? Your cameras, your radar are actually observing the world, and that's what you need to give the system as the input so that it doesn't see a difference between the simulator as well as the real world. Okay, and I'm going to illustrate in a couple of videos, the really high fidelity of our sensor simulation that is very different from what you see out there, which combines physics as well as AI. Finally, you need to be able to create all the scenarios at the scale that reflect all the possibilities and things, including rare cases, safety critical cases, so that we can test at the scale. And finally, the simulator is just not a simulator for testing. You can also train the system in the simulator. Every time that you observe or you are running the simulator, the system gets better and better and better. Okay? So that's a big, groundbreaking, I would say, technology compared to what is out there in the industry. All right, so let's give some examples here. So what we're going to do is the following. I'm going to show you a little snippet captured in San Francisco. In this case, is the Bay Bridge, for those of you that know the Bay Area. And we're just going to drive around with a couple of cameras and a radar And then we're going to automatically import that in the simulator. And then what I'm going to do is I'm going to play God, and I'm going to be changing what happened in the simulator. Okay? And we're going to resimulate this so that you see how high fidelity our simulations are. All right, so everything that you see on the left is going to be always the same snippet, is the original data. And everything that you're going to see on the right is every pixel is resimulated. Okay? All right, so the first thing that I did here is for you is I'm going to generate the, as if we were driving in this street and there was no traffic. I wish this was, something that you could capture, but, San Francisco traffic is terrible. All right, so you see, the high fidelity of, how well we can actually reconstruct the static part of the environment. Next thing that we're going to do in this case is that we are going to take one of the actors and we are going to change what they did, okay? So that we change the scenario. So in here, the white car that was taking a left turn, we're going to change its behavior to abort the lane change and then go back to our lane. Okay? Right-hand side, all simulated, super, super realistic. You don't really see much of a difference, right? Next, we are going to add an additional vehicle that was not there in the first place. This is the second vehicle on the right-hand side, right on the right lane. Okay, so you can modify behaviors, you can add actors that weren't there in the first place, you can remove as many actors as you would like, right? And now we're going to also have some fun, and that is interesting. So we have some corrupted video, so apologies for that. That's not supposed to be looking like this in the simulator. Oh God. Anyways, where we actually, interesting codec issues, where we actually flip who is doing which behavior, right? We take these two cars and we flip them. And yeah, come and see my laptop. I can show you this, how it really looks in reality. All right, so again, very, very realistic the way that we do this. Now, you need to go one step further, right, is since you're going to modify your behavior, the way that we drive in the simulator, right, potentially we're going to take a right turn or something different, we also need to simulate different viewpoints. And that's what this video is showing now, that now we're going to move the vehicle to be driving on the right lane, our own ego vehicle, right? And then you can simulate how will this scene look like if I was driving on a different lane. Okay? So this shows you kind of the capabilities that the simulator has that you can utilize together, right, so that you can modify reality, you can really resimulate everything in a way that is new to create all this unbounded number of scenarios, safety critical cases, accidents, whatever you want, right? And then you can test all these things, right, with a domain gap that is almost zero, so that you can really validate and verify your systems in the simulator. Alrighty, so now we can utilize all this, then create these scenarios, and then make the Waabi world to be reactive to us. Okay, before I was just showing the simulation of the sensors. Now we are going to react to the different environment, and the environment is going to react to us. Okay, and then in the back end, right, all this sensor simulation is happening, and the vehicle is controlled by our brain of the self-driving vehicle. Okay, so again, you're just basically replaying or driving, right, as in a video game. But in a way that is very, very realistic. All right, so oftentimes people ask, how did you create these scenarios, right? So there's many ways that we can do this. We can do it programmatically. If you're a safety engineer, you want to test a specific thing, you want the ability to really control everything. So that's with a few lines of code, you have your new scenario, and you can run it, with variations at the scale super quickly. You can do it with modifying reality. This is what I did before. Right, is I took a scenario that happened and then I started playing with it, right, to show you some stuff. We can also generate this with deep generative models, okay, so that you have models of traffic. You can also generate the backgrounds, the environment, the maps, everything with deep generative models as well. And this gives you the ability to simulate, at large, just traffic and things like this. But, even though this is, super rich, it's not sufficient. Why do I say that? Is because when the brain of your self-driving vehicle is actually really good and performant, it's really hard to fail. And the question that arises is, if let's say that I have, a million scenarios or a billion scenarios and I pass them all, is it safe enough? Right? Have I tested the entire coverage of the environment? So maybe not, right? So we need one more tool, which is we need to be able to very quickly create scenarios that, with high probability, will make us fail. Okay? And we do this through adversarial scenarios. And since the simulator is an AI system, the brain is an AI system, so you can make them play against each other. Okay? And it's learning to, ooh, I didn't like how you're actually, doing this lane change. Let me put you a slightly more difficult scenario and see whether you fail over here. And that's the way that very, very quickly you can really discover where your issues are, right? And this is very important because you don't want to go on the road and start testing and then discover, a safety hazard. You want to do it in the simulator. You want to be able to say, I certify that actually, I can, with very high probability, I will never have an issue. Okay. And the other thing that this simulator, which is very exciting, is that you can actually validate and verify the simulator, and it's the only one out there that you can do this. Cool. All right, and last but not least, right, so for those of you that are fanatics of RL and other things that you can do, you can actually learn on the simulator. So I'm showing you here, we have a simple agent that is having difficulty, it's trying the scenario, it's crashing, and it's learning to be a little bit better. Right? This is actually a fairly difficult merge where it needs to learn to accelerate, so it's very long-term reasoning in order to be able to merge properly. Okay? So it learns, by experiencing the simulator to, handle difficult situations. All right, so all of this together enable us to really not need to drive all these millions of miles. Okay, so this technology allows you to be cost efficient, much safer, highly scalable, and highly flexible, so that we can really expand this technology, super, super fast to new geographies, new configurations, and integrate with our OEM partners. Okay. So very exciting to show you today this, and I want to finish with one sentence, which is that the future of diesel-driven trucks, and in particular Waabi trucks, are really much closer than you think, and I can't wait to show you this. Okay, thank you.